For context, this is the bike that my customer is building. This was legitimately a customer who contacted me asking me for an air intake for a Honda Grom conversion from the 125 motor to the 300 CBR motor. I found the STL file, changed it to one that would actually be printable for my printer, and away we went with this. Not bad for a first gig.
Hey guys, welcome back to the channel. This is going to be our second print. Our first print was this little guy, as you saw in the previous video, and I tried it out in the water. It floats like this. This was a test print, and our settings are pretty simple. For this print, I have it set up for fast, and we can do higher quality stuff. I put support structure on. If I take it off, it'll change it to 3 hours. But I looked online, and there's warnings if you don't. So it saves me 30 minutes. It's not worth losing that entire print. So PLA is what I'm going to be printing in, and it's this common PLA, nothing too special. And this is an elbow adapter for an air intake for the Honda Grom 300 conversion. So we're going to start printing this. So I'm currently preheating to 200 degrees. We are at 115 and climbing. 70 is the bed temperature, which is this guy here. And we are at 33 and climbing. So we're almost at temperature. The SD card is in. We're going to print from TF card. And I changed it to the G code format. So we're just going to hit print, and it's going to start up. And we'll check on it periodically. But basically what it's doing is building a raft for the cold air intake elbow for the Grom conversion from the 125 to 300 CBR. And we have this beauty I'm going to put in time-lapse.
So using a security camera to check on the 3D print is awesome. Mine's a Waze pan-tilt zoom camera. It's only like a digital zoom or something like that, not an optical zoom, but it still gets the job done. And this time I set it up into time-lapse because I have a memory card built into it, or sorry, plugged into it. It's nothing special. It's 1080p, does what it needs to do, and I'm able to watch the 3D print just in case there was some printer overrun, say the PLA, which is the plastic that's being used in this case, gets stuck or knocks over the print. I'm able to see what's going on and be able to fix it before the printer just goes in full chaos mode and I walk into a giant pile of used up PLA because I haven't learned yet how to reuse that stuff, if it is even possible. That's something to look forward to in the future, if I learn how to recycle any filament material back into projects. If that's the case, I may or may not need like a plastic grinder to get it all down. Then I have to melt it and extrude it into a filament itself to be able to reuse it. And then that question is it 100% recyclable, or do I have to add in extra material to have it work again? So what we're doing here is building an air intake for a Honda Grom conversion to a 300 CBR Honda motor. And in doing so, you're going to need to add a space for the sensor. And there's all sorts of sensors. Basically, they measure air coming in, and they dictate the amount of fuel mixture to run the engine properly. I found a video about this.
Engine sensors and what they mean. This might get very confusing. First is the mass airflow sensor. You'll see this between the airbox and the throttle body. Now, what this sensor does, it measures the amount of air going inside of the engine and is used to calculate fuel that needs to be burned for that air. For example, that sensor has either a hot wire or a hot film that as air passes over it, there's a cooling effect, and the ECU knows how much fuel that the engine needs at that time. If you have a bad mass airflow sensor, you'll typically have a hard start. It'll run very, very rough. You get poor gas mileage. So yeah, if you have any of those issues, look at your mass airflow sensor and pull your codes. Next is map sensor, manifold absolute pressure. So if you're at sea level, you're at atmospheric pressure of 14.7. So with a manifold absolute pressure sensor, what it's gonna do is it's gonna read the amount of pressure in the manifold from absolute zero vacuum all the way up to whatever it's reading. So for example, if it's reading 20 PSI on your map sensor, you're making right around 6 pounds of boost. I checked the math, it's 5.3. Bad map sensor is usually going to throw a code, and then also the engine symptoms are kind of similar to a bad MAF. It's going to run rough, bad gas mileage, it's not really getting the right signal to the engine. So yeah, but these are much cheaper to replace than a MAF sensor. IAT, or intake air temperature sensors. Now these are going to measure the temperature of the air that is going inside of the engine. Cooler air is going to mandate more fuel because cooler air is more dense with air molecules. Hotter air is less dense. At the same time too, hotter air is more prone to pre-ignition. So this is a sensor that's very important in the longevity of your engine. Usually with bad IAT sensors, you're gonna have an engine that runs very, very rough. You're gonna have it run very, very rich as well because it's probably gonna default into where it thinks it's always cold, and then it's always gonna be adding more fuel than it really needs.
So guys, the 3D printed intake for the 2015 125 Grom has completed for the engine conversion to a 300 CBR motor, and it is 2:15 in the morning, and the print says it's going to take 4 hours and 1 minute. 4 hours, 1 minute. Took 5 hours, 11 minutes, and 47 seconds. Interesting. Still, pretty cool. Did a little time lapse with my secure camera, you know, the waves there. So hopefully that turned out. But I woke up, I didn't set an alarm or anything like that, so it wasn't too big of a deal. Let's, can this pop off? Yep, there we go. Okay, so this was a pass because it had the structure. This was a fail. I can see why. I was surprised it didn't give its, what do you call it, print structure for here to support that, to make this perfect. It did all the structure for the bottom here. Interesting. Everything else looks like it turned out everything did turn out really well. I'll send pictures to the customer and see if they still want it. Because to me, this area is not that bad. I would just use, what do you call it, a little bit of epoxy, and I'd finish that off. But yeah, she turned out okay. I'm gonna have to get him to send pictures of the modification. I've got them already, but I'm gonna get some pictures from the bike and I'll post those later. All in all, the quality is pretty good. So guys, I can now print parts for automotive. And this was what was suggested to print it out of the PLA. Not, I would like to prefer to print it out of ABS. And this here is for what I believe to be the either the injector or the mass airflow sensor for the bike can understand what the air temperature is at. It's one or the other. They say online I read injector, but I think it's probably the mass airflow sensor. But yeah. So if you like what I do here, please like, share, and subscribe, and I'll catch you guys in the next one. Peace.